So now to a bit of geometry. First of all, to be able to work out the length of a line. In order to work out the length of the line, you have to work out the difference in the x coordinates and the difference in the y coordinates first. In other words, drawing a right angle triangle on, as long as you know what that length is, you can find the length of the line using Pythagoras' theorem. So with Pythagoras' theorem, you work out that distance squared, add it to that distance squared, and once you've worked out that, you square root. Formula. Now, whilst I've got this one on here, another thing you should have learned at GCSE, which is important at A level, is the gradient of a line. So the gradient of a line at A level we class as M, and M is equal to the difference in the y coordinates divided by the difference in the x coordinates. Gradient. Secondly, to work out the midpoint of a line, if you know the two n coordinates, the easiest way to do is add the x coordinates together and then half them, i.e. the average of the x coordinates will give you the x coordinate in the middle, and likewise for the y coordinates. Add the y coordinates together, divide by 2, the average of the two y coordinates would also give you the middle point for the y value. Okay, so to find the distance between A and B, we first of all need to establish how far across we've gone. Well, we've gone from 1 to 6 across, so that's 5 units across. We have to establish how far up we've gone. Well, -2, there's 2 units there, up to 10, that's a total of 12 units. So the distance of A to B would equal the square root of 12 squared added to 5 squared, which is equal to the square root of 144 plus 25, so 169, which is 13 units. So no sketch given, we can establish the distance by arguably drawing a quick sketch. 1, -2, 1, -2, 6, 10, 6 across, 10 up. So to work out that distance from there to there, we can see how far across we've gone, how far up we've gone, and we're away. So from there to there, we have gone 5 across. From there up to there, we've gone 12 units up. So therefore, the distance from A to B is equal to the square root of 12 squared added to 5 squared, which calculated or otherwise is a square root of 169, which is 13. So to establish the gradient of a line, again, a sketch would make this arguably easier to see. 1, 4, 3, 8. So to establish the gradient, we can see that we've gone across 2 units from the 1 to the 3, 2 units across. We can see that we have gone from the 4 to the 8, we've gone 4 units up. So the gradient, which we, as I've already said, put as M, will equal 4 shared by 2, which equals 2. Again, draw a sketch. 2, 1, 7, 11. So to establish the gradient of that line, the difference in the x coordinates is 5. The difference in the y coordinates is 10. So the gradient is equal to 10 shared by 5, which is once again 2. Third example, again, draw a sketch. This time at -3, we're up at 7. At 1, we're down at -5. We can see that we have gone across a total of 4 units, i.e. 1 take -3, for example, is 4, or -3, -1, -4 is 4 units across, nevertheless. We can see that going up 5 units and 7 units, so we've got 12 units, or arguably 7 take -5 is the same as 7 plus 5, 12 units, or -5, -7, -12 units. Bottom line is though, with this one, the way I've just done it, got to be careful, because that 12 is a drop of 12, and we've got across 4. What I'm getting at is that gradient is -3, not +3. But you should know that from your GCSE days, that the line is going down, therefore negative gradient. The power of a sketch. Now, throughout your GCSE days, you will be taught that the equation of a straight line is y equals mx plus c. As I've used in previous example, m stands for the gradient of the line, and the value of c is the y-intercept. In other words, where it crosses the y-axis. So in the case of the first question, A, we can see that the gradient is 3, and we can see that the value of c, the y-intercept, is -2. Likewise, in the second question, we can see that the gradient, how many x's have I got? I've got -1x, the gradient is -1, and the y-intercept is +3. As for the third one, we have to do some work first of all. So here I would write that 2y is equal to 6 take 5x, trying to rearrange for y being the subject. If I then divide by 2, I get 3 take 5 over 2, or 2.5x. So the gradient is -5 over 2, and the y-intercept is once again 3. Now the y equals mx plus c can be used even at A level. However, as showed at the bottom of that slide, there is a better equation to use for many A level problems. Now this comes from your knowledge of how to establish the gradient. The gradient is equal to the difference in the y coordinates divided by the difference in the x coordinates. Now if I give you one coordinate, x1, y1, and the second one is anywhere up and down that line, so it's anywhere up and down that line, then that would be an expression for the gradient. If I take this across the other side, it becomes multiply, so I end up with m lots of x minus x1 is equal to y minus y1, the expression you see there. Because in many situations, you do not know where it crosses the y-axis, and therefore this is more advisable than the y equals mx plus c. Though y equals mx plus c could be used, this is a better alternative. So this example makes use of what I've just shown you, and the y coordinate is a 3, so I'll replace the y1 with a 3. The x coordinate is a -1, so I'll replace that with a -1, so minus -1 makes that a +1, and the gradient is a 2. So we would write that y minus 3 is equal to 2 lots of x plus 1. If I remove the bracket, I get 2x plus 2. So y take 3 is equal to 2x plus 2. So y is equal to 2x. Bring the 3 across, becomes plus 3. So I end up with plus 5. There is your equation of that line. Now the other difficulty with this one is that we haven't got the gradient, we haven't got m. So if I draw a sketch, then at -1 we're up at 3. At 1 we're up at 9. We can see that the gradient of that line is 2 across, 3 to the 9 we've gone 6 up, so the gradient of that line is 6 shared by 2, the gradient is 3. Now the problem's no more difficult than the previous. We have got choice though for the coordinate, it doesn't matter which one we use for the x1, y1. However, if we can avoid a minus, we avoid it. So we've got y take 9 is equal to 3 lots of x take 1, using the 1 and the 9. So y take 9 is equal to 3 lots of x take 3. So y is equal to 3 lots of x, bring the 9 across, becomes a plus 9, so we have plus 6. As with the previous, draw a sketch to assist to find the equation of this line. So at 2 we're at -4. At 4 we're up at 1. So we can see that we've gone 2 across and we have gone 5 units up. So therefore the gradient of that line is 5 over 2 or 2.5, though I'd rather leave it as 5 over 2. Because when we use the coordinate, again I'm going to stick with that because there's no negatives in there, we have y minus 1 is equal to the gradient x minus 4. Now I could remove the bracket here, but it is advisable to take that 2 across the other side. And the opposite of divide 2 is times 2. So if I times the other side by 2, I get that. That means on this side, I have got 5 bracket x take 4, which at that stage you could remove and have it as 5x take 20. So 2y take 2 is equal to 5x take 20, and at advanced level it's fine to leave it as 2y equals 5x, and bringing the 2 across becomes a plus 2, so minus 18. There is no need to have a fraction answer.